Hey Math 30-1s, welcome to the second day of problem solving using trig functions and graphs. So like I had mentioned yesterday, the difference between today's lesson and yesterday's lesson is that today's lesson will be asked for the most part to also come up with the equation that we're going to use to solve whatever questions it is that they throw at us. If you remember from yesterday, they gave us the equations for the most part, the parameters a, b, c, and d, their values, and then we either graphed or used an algebraic process to come up with the solutions. So you'll see today they give us a graph or a picture or a situation. We will come up with an equation, usually based on sine or cosine, and then from there answer whatever question they are asking us. So in the warm-up here, just the review, it says this: the sinusoidal wave shown has a maximum value of 50 and a minimum value of 10. Write the equation of the sinusoidal wave in the form h of t equals a sine b t minus c plus d. And again, an important thing here is that a is bigger than 0, which means that the a value is positive. It is not negative. There is no reflection. Okay, so we are looking for the graph of sine. Okay, and we do have all four of these parameters to figure out. Okay, so that's kind of where we're going with this question. So I'll start with the a value kind of as we usually do. Now a, remember, that value is calculated or directly correlated to amplitude, which is max minus min divided by 2. So they tell me in this question my max value is 50. I'm going to subtract the minimum value, which is 10, and then I will divide by 2. So when I calculate that a value, you're going to have 40 divided by 2, which is 20. Okay. From there, I usually go right to the d value, which is the vertical displacement, because the formula is very similar, except we add the max and the min values. So 50 plus 10 divided by 2, which will give me a value of 30. Now, if you remember from previous days, once I find that vertical displacement, I go to that value on the y-axis and I kind of draw in a new x-axis at that point. Okay, so that's what I'm going to do here. I'm drawing a horizontal line, or kind of like a new x-axis at that point. I still treat the y-axis as my original y-axis. That larger point there, I treat kind of like my new origin. And because we are looking for the graph of sine, where there is or has been no reflection, I am looking for this general shape, okay, along that new x-axis and the y-axis that I have drawn in red. Okay, that's what I'm after there. So what I do next is go after the parameters b and c. So to find the value of b, remember it's going to be 2 pi, because that is the normal period length of sine, and I'm going to divide that by the period length of the graph that I have in front of me. So first thing I want to do is try and determine what the period length of this graph is. So if I start at that origin and I kind of trace the graph, I'll do this in blue, but I trace the graph here, okay, starting at that new origin and up, there we go. Okay, there would be one cycle of that graph. So at this point right there, we would be starting a new cycle of that graph. And so from here, which is 0, up to where I drew that vertical line down there, that's 32. So the period length of this graph is going to be 32. So the b value that I enter into the equation will be 2 pi, the normal period length of sine, divided by the period length for this specific graph. Okay, and that will reduce to pi over 16, right? The numerator and denominator are both divisible by 2. So there's my b value. Now, the phase shift, which is the c value, okay? Again, remember, we are looking for the graph of sine to start here, that I'm circling in this graph in the top right-hand corner. That value, okay, should be starting right here on this graph. It does not. It starts right here, okay? This is where the graph is now starting, that shape of sine. See, it goes up, it comes down, and then it goes back up. There's that shape that I was after, okay? But it's starting here, and this point is right here at 16. So the graph has shifted 16 units to the right, okay? So the graph has gone 16 units to the right, from here to here, okay? 16 units to the right. So now when I go and write my equation, okay, I follow the outline they've given me. H of t, that's your y value, is a, we said that was 20. Sine of, okay, your b value was pi over 16, t minus 16, 16 units to the right, and then a vertical displacement of 30. Okay, and there you go. So A, B, C, D. Okay, and we are done. That is how the equation that represents that graph, which was given to us in the question. Okay, so we're going to be doing stuff like that today. So remember, you're just kind of after those parameters A, B, C, and D. And it is good to get that equation, but then they will usually ask us some questions after we get the equation, as you will see in the following 2 examples. Okay, there's only 2 questions today. They're a little more in depth, but there's only 2. So class example 1 here reads like this. A nail is caught in the tread of a rotating tire at point N. Okay, so you locate point N, okay, right there in red that I've put on the graph. So that tire is rotating, it's turning, it's moving on the ground, and the height of the nail goes up, it goes down, hits the ground, goes back up, okay, and you can see it creates a sinusoidal wave. Now, after the graph, okay, it says here, the tire has a diameter of 50 centimeters, okay? So why is that important? Well, that means that the diameter, okay, the highest this tire goes is 50, and obviously the lowest it goes is 0, right? Because the tire has to touch the ground, and its maximum height, the diameter, like it says, is the distance from edge to edge, but traveling through the center of the circle. So the maximum height of this tire will be 50, as I have labeled there. And it rotates at 10 revolutions per minute. So here's the interesting thing that they've told me. They've told me that this tire has 10 revolutions every 1 minute, okay? That's great, but the issue is that time, if you read the x-axis, is here and it's in seconds. So what I need to do is I need to do a little bit of unit conversion here. So 10 revolutions in 1 minute is the same thing as 10 revolutions in 60 seconds. So I just changed the 1 minute into 60 seconds. But I'm not interested in 10 revolutions. I want to know how long it takes this tire to do 1 revolution, because that's going to be the period length, isn't it? 1 revolution is the period length. So if you take a look at the numerator and denominator, you can divide them both by 10, and what you end up with is 1 revolution every 6 seconds. Now, this is your period length, okay? So what that is telling you is that 6 seconds is your period length. So that height of the nail, which we started right here, when it hits that same point, which will be right about here, okay, that is going to be 6 seconds. That's how long it took, okay? So what I can determine from that are other points on the x-axis. When I take a look at the graph of sine, for example, okay, which I'll just draw over here, okay? When I draw the graph of sine, okay, like this, okay, it's symmetrical. I can break it up into 4 equal quadrants, okay, symmetrical quadrants. 1, 2, 3, and 4, like so. So I can do the same thing here with the graph up above. If I know that that's 6 seconds, okay, this point here, okay, knowing that I started at 0 will occur 4.5 seconds after the original nail has started to rotate. This point here, okay, right there would be at 3. And then this point up here, okay, would be occurring right here at 1.5 seconds. So you can see my scale is every 1.5 seconds is what I've labeled there. So if you keep going, okay, this maximum point up here would be 1.5 later, so that's 7.5. This point here, where that nail is at the same height, okay, would be 1.5 later, which is 9. Okay, and then it's back here on the ground, 1.5 later, so there's 10.5. So now I have a really good scale on my x-axis based on, okay, what I figured out in terms of the revolution, the period length, and how I label that x-axis. So that's kind of part A. Okay, use the information to write a scale for each axis. And again, if you even read the question, it says after 4.5 seconds, the nail touches the ground, okay, which is this point right here that I'm circling, okay? And I was able to figure that out on my own anyways, but they just give me that information as kind of a double check or a verification of what I've just done graphically. So now we move on to being able to determine the equation. So when I look at that equation, again, some things I want to point out. That when they tell me to write the equation, they're only looking for an A, B, and D parameter. That means there is no C, there has been no horizontal phase shift. And again, okay, A is greater than 0, no reflection, and we are dealing with the graph of sine. So we are dealing with this general shape over here. Okay, that's what we are after. So when I go and calculate the parameters, A again, the amplitude, max minus min. Okay, so max minus min over 2. So your A value will be 25, okay? Then I go and I calculate the vertical displacement, okay, max plus min, divided by 2, which in this case is going to give me another value of 25. So what I need to do now is calculate the B value. So the B value, again, will be the normal period length for sine divided by the period length in this question, which was 6 seconds. 2 over 6 reduces to 1 over 3, so pi over 3 is my B value. So now I'm able to go and write the equation for this function, which will look like this. H of t is equal to an A value for the parameter A, 25, sine of pi over 3t, and then I add the d value, which is 25. So if you want, feel free to put this in brackets to, make sure it is separate from the vertical displacement. So now they ask me a question. How far to the nearest tenth of a centimeter, so 1 decimal place, is the nail above the ground after 6.5 seconds? Well, this 6.5 seconds, remember, that's a time, that's t. So you have two options here. Either graph the function on your calculator and hit trace, enter an x value of 6.5, and your calculator will calculate the y value or the height for you. Or I can use the equation algebraically and figure out the answer. So I want to know the height at 6.5 seconds. Okay, this is the way we notate it. 25 sine of pi over 3. Okay, now I enter my value of 6.5 seconds, and then I add 25. Now remember, when I do this calculation, it should be in radian mode. And the way we do the calculation is this. As I deal with this first, I multiply those values together first. Then I take the sine of whatever value is inside the brackets, take that, multiply by 25, and then finally add that 25 at the end. Okay, so when I do that, I will get a value of 37.5. That is a height, and the units will be centimeters. Okay, so practice that both graphically, graphing the function on your calculator, and also solving it algebraically. Now remember, when you do this graphically, you need to have appropriate window settings so you can see this graph properly. X minimum, okay, so if I were to do this graphically for my x's, okay, the minimum could be 0. The maximum could be, if you take a look at my x-axis, 10.5 or even up to 12. Go a little past what I did on the x-axis. And the scale, just like we did there, is 1.5. For the y's or your range, you could go from 0. It goes up to 50, so you could go a little higher, like 60. And again, the scale there could just be 1. And then you'll have a good window setting to see that graph properly. And then everything should be A-okay. All right, let's turn the page and work on the second question. Now, on the second question, okay, they talk about a Ferris wheel. So it says the first Ferris wheel ever built was created by a bridge builder by the name of George W. Ferris in 1893. Okay, very fascinating, but not really needed to do any calculations in this question. The diameter of the wheel, so again, important diameter, okay, edge to edge, circumference through the center of the circle. Okay, so from one not circumference, but from the outer edge of one side of the circle to the outer edge of the other side of the circle, but going directly through the center. Okay, so that diameter was 76 meters, and the maximum height of the Ferris wheel was 80. So there you go. There's your maximum height. The wheel had 36 wooden carts on the wheel, and each cart was able to hold 60 people. So again, nice information, but not needed in order to write the equation that they're going to ask us to do here. So the Ferris wheel was introduced at the 1893 World's Fair in Chicago. The illustration below is a copy of the photograph of the original wheel. So a couple things. They've given me some nice information in the write-up of the question, but also this chart right here, okay, giving me my X and my Y values, is also important. It's kind of a lot the same information, but again, points I'm going to be able to plot on the grid so that I get an appropriate graph that I can study and create an equation from. So A reads like this. Now, if the wheel rotated every 9 minutes, okay, so what have they told you there? They've automatically told you what the period length is, haven't they? Okay, because it rotates once, okay, every 9 minutes. So the period is 9 minutes. Okay, that's pretty easy to see from the question. Use the data in the table, okay, to sketch a sinusoidal graph which represents the height of the car in meters as a function of time in minutes. Assume that the car is at its lowest point at t equals 0 and draw one complete cycle. So again, just going back to the table and the period, if you notice at time 0, the height was 4. When's it back at height 4? 9 minutes later. Okay, so there you go. That's how you know also that the period length is 9 minutes. Now, I'm going to use the data from the table, plot some points, and then we will study this graph. So here's what happens. They tell me at time of 0, I'm at 4. So 4 is going to be right about there, not quite halfway between 0 and 10, which is the scale on the y-axis. Okay, 2.25 seconds later, okay, I'm at 42. So you go to 2.25 and up to 42, so just above 40. Okay, so there's 2.25 and 42. Then I go to 4.5 and 80. So 4.5 and 80. Okay, that might be right about there. And that's the maximum height, right? They told you the maximum height was 80. Okay, and that occurred at 4.5 seconds. Then I work my way back down. So 6.75 seconds. Okay, at 6.75 seconds, I'm back at 42. So 6.75, back at that height of 42. And then finally at 9 seconds, I'm back down here at 4. Okay, so there are the points that were created from that table of values. So when I go and sketch my graph, okay, it's going to look something like this. I know it's going to be a sinusoidal function. Okay, so I'm doing it the best I can, which I know you guys will as well. Okay, through these points and back down like so. Okay, so there you go. There's what the graph looks like based on the table of values. Okay, and again, like I said, I'm highlighting it or circling here. They told me it's going to be a sinusoidal shape, and we're good. Now, moving on to what they actually want. Determine the equation of the graph in this form. So this time we're talking about a cosine graph, okay? And I do have parameters A, B, C, and D. So remember, when we are talking about the graph of cosine, okay, cosine starts at a maximum value and goes down and then back up and finishes at a maximum, okay? So that's what we're looking, that shape is what we're looking for based on the red graph I drew up above. So I should be able to figure out some of these parameters right away. So A, okay, is going to be your amplitude max minus min divided by 2. So the maximum height that this graph or this Ferris wheel went was 80. The lowest the graph goes is 4, okay? A Ferris wheel cannot go to a height of 0, okay? If it goes to a height of 0, that means when it rotates, it would crush whoever's ever in that cart as it goes on the ground. It's not a tire. It doesn't make contact with the ground. So there has to be some clearance from the ground. So the minimum height that Ferris wheel went was 4. And then I divide by 2. So 80 minus 4 divided by 2 is 38, okay? So there is that value. And again, as always, I usually jump right to D, or the vertical displacement, because that will be 80 plus 4 divided by 2. Okay, so that's 84 divided by 2, which will be 42. Okay, so we get those out of the way. Then I can figure out what my B value is going to be. So remember, your B value is the normal period length for cosine divided by the period length for this graph, so 2 pi over 9. And remember, if you remember from the other day, sometimes they leave your period length as 2 pi over a value, and that's the case here because I can't simplify 2 over 9. So 2 pi over 9 is the B value I will be entering into the equation. Now, the C value, okay, which is the phase shift, remember, we are looking for a maximum and then on the way down. So if I go back up to my graph, where is that? Well, here it is. Here's the maximum, and then it goes down, just like the graph of cosine should do. That point here, this maximum on its way down, should be starting on the y-axis. That's where cosine starts. So that means it should be here, but it has moved to here. So that means, if you take a look, that how far was that movement? Well, that was 4.5 to the right, the graph went. It should be starting on the y-axis. It's not. It's starting 4.5 minutes or units to the right. So the C value will be 4.5. So what I do now is I write my equation. Therefore, my equation will be h of t is equal to, the A value is 38. It is cosine of my B value, 2 pi over 9. Okay, now my phase shift, t minus 4.5. Okay, close the bracket. Okay, I will have to get rid of this graph for right now. And then I finally add my D value, which was 42. Okay, and there's your equation. So 2 questions again. One will probably give me the x value, ask for the y, and the other one will give me the y and ask for the x. So how high? That's the height, right? How high is the cart 5 minutes after the wheel starts rotating? So again, if you prefer to graph this on your calculator, that's great. You can use it. You can trace, Enter, in this case, 5 minutes. Okay, that's time. That's time. So you're going to enter or trace an x value of 5, hit enter, and your calculator will tell you what the y value is. Or you can use the equation. I want to know the height at 5 minutes. So I take my equation, 38 cosine of 2 pi over 9. This will now be time, okay? And the time in this case, like I said, was 5. So it'll be 5 minus 4.5, and then you will add 42. Okay, again, your calculator should be in radian mode, and the calculations in order will be what? Well, you're going to do 5 minus 4.5 first, multiply that then by 2 pi over 9, take the cosine of that whole value in the brackets, multiply by 38, and then finally add 42. Okay, and when you do that, okay, you should be getting to, what does they ask me to round here? To the nearest meter. So just your standard rounding rules. Above 0.5, we round up. Below 0.5, we round down. So this will take me to 78 meters. Okay, that's the answer. Now in D, it says how many seconds after the wheel starts rotating does the cart first reach 10 meters? Okay, so how many seconds time, so they're after the x value this time, does the wheel start rolling? Will it first reach 10 meters from the ground? Okay, so what you're interested in really is this point right here. Okay, that's what you're after, right? You want to know this value right here. That's what you're after, that time. So you can see it's before 1 minute, isn't it? Okay, so what we're going to do to solve this graphically is the following. I would graph y1, okay, as the equation that we produced from the information. So 38 cos of 2 pi over 9 t minus 4.5 and then plus 42. I will then go and graph a second function at the height. So I'm going to graph y2, which is at 10. Then what I want to do is I want to find where those graphs intersect, okay? So what you're going to see is something like the following, right? Here is my, like I said, my original cosine function that did this. I'm going to be graphing y equals 10, like this. And notice they said when it first hits 10 meters. You can see there's 2 intersection points, but I'm after this intersection point right there, okay? So I'm going to graph both of those, and I'm going to find the intersection point, okay? So when I do that, that intersection point here, this x value or t value, okay, ends up being 0.1859, okay, etc. Okay, now it says how many seconds. That's the question, right? How many seconds? Well, remember time here it was in minutes. So what I've got is 0.8159 of a minute. So what I have to do is take that number, the 0.8159, and multiply it by 60. Okay, so when I do that, I get 48.955 approximately, and they want it to, how many seconds? So that's 48 and a bit seconds, so the answer is 49 seconds. Okay, and there's your answer. So again, because they asked for the answer in seconds, I knew it was before 1 minute, so I can answer in seconds anyways, but just be careful that you're matching up the units, what they want as a calculation and what that scale on the x-axis actually is. Okay, so again, a lot of information there, a lot of practice needed. Very important, though, being able to determine those parameters A, B, C, and D in those trig equations for each function. Practice that. We are done the first section of trig, okay? You are going to be having a test, but not on this section alone. It'll be on both trig sections together, so just one big large trig test. We will be giving you a date for that coming up probably in the next week or so, but stay tuned for lessons coming up starting again on Monday. I hope you guys have a good weekend. Practice that, and as always, any issues with these questions or any of the material, get a hold of me. I will help you as soon as I can and to the best of my abilities.